Hey, it's T. I'm one of the geniuses at Ask Zylor. So let's just get started with the live session.
All right, so we're going to go ahead and get started with the first one. So this is a grade 12 advanced functions question. We're dealing with exponential forms. So we're asked to find what this t variable is. Okay, so we have 80 is equal to 85 times 1 over 2 to the power of t over 20. Okay, so what we should do is isolate for this term. So I'm going to get rid of the 85. So I have 80 over 85 is equal to 1/2 t over 20. And then I'm going to reduce the left side by just dividing both the top and the bottom by 5, which leaves me with 16 over 17. This is equal to still 1 over 2, t to over 20. So now I need to find a way to isolate for the t variable. So what I'm going to do is take the logarithm of the left and the right hand side. Right? So when I just say log, I mean the log base of 10. Okay? So when I do that, this is 1 over 2 to the power of t over 20. Now, when I take the log of the right-hand side, the power ends up being the coefficient, right? That's one of the logarithmic rules, or the log laws. So anytime you take the log of something that has a power, the power can be brought down as a coefficient. So now I have log of 16 over 17 is equal to t over 20 times the log of 1 over 2. Okay? So now it's a matter of isolating for that t variable. So t ends up being log of 16 over 17, right, divided by the log of 1 over 2. And then I'm going to bring the 20 over to the top, so I have 20 in my numerator. So this is my t variable. I can plug all this into a calculator to give me roughly 1.75. So we're going to jump to the next question. So this is a grade 9 math question. So we're told this place charges $9.50 per hour to rent a boat. Describe the relationship between the cost of the boat rental and the time in hours that the boat is rented for. So let's do that first. So my cost, I'm going to say it in C, and time, I'm going to say it in T. Right? So we need to find a relationship between these two. So we're told that it charges $9.50 per hour to rent a boat. So I'm going to say my cost should be the charge, which is $9.50, times how many hours I have, right? So if I use the variables that I've chosen before, I have C equals 9.5 times T. Okay, so illustrate the relationship graphically. So when this is already done for us. So when we don't have any constant added at the end and we just have the variable times some number, that means this ends up being my slope, right? My slope is 9.5. My y-intercept, or my b value, is 0. That means I'm starting at 0, right? And then my slope should have a rise over run of 9.5. And then I can plot this as long as I want to, right? So we'll just do part C and go to the next question. So use your graph to estimate the cost for renting the boat for 12 hours. So if we do this for 12, we can go all the way up to t is equal to 12 and find out what the C value is. Right? So if we want to make an approximation, my C value is about 115, let's say, right? When my T is equal to 12. Okay, so once again, we're just going through some questions that we see commonly throughout the week and questions that students have been sending in. So if you have any questions that you want us to do, send us a message. We'll be happy to incorporate them. So let's go to the next one. So this is another grade 9 math question. So we're doing a bit more grade 9 questions because the EQA is coming up. So if you need any help with them, if you have any questions about them, send us a message. So this is a Pythagorean theorem application question. So we're asked to use that to show whether the table can be turned inside the room without lifting or tilting it. Okay, so we're given the table, we're given the room. What are we going to do? We should be finding what the diagonal of this is. Okay, the reason being is that's the longest side in this table, And if my diagonal doesn't fit the width of this loom, I can't rotate it without lifting or tilting it. Okay, so how do I find this diagonal? I'm going to use the triangle and the dimensions they've given to us. They've told us this is 80, this is 120, right? And the diagonal I'm going to find using my Pythagorean theorem. And they've told me the width of the loom is 140. So my diagonal has to be less than 140 in order to rotate it, right? So let's go ahead and find that. So my diagonal squared is equal to 80 squared plus 120 squared. Right, so if I get the square root of 80 squared plus 120 squared, it should give me roughly 144.2 centimeters. I think those are units, yeah, centimeters. Since my diagonal is bigger than 140, that means I can't really rotate it without lifting or tilting it. So we're again dealing with a grade 9 math question. We're just dealing with exponents. So we're given this expression, we need to find the missing exponent. Okay, so let's say my exponent unknown is going to be a. That's in there. So how do we find that? We need to know the exponent rules, right? If we multiply two terms that are the same with different exponents, a times b, I'm going to add the exponents together, right? If I divide two terms with the same base and different exponents, I subtract the exponents together. Okay, so knowing this, we can set up an equation to solve for what the missing exponent is. So I said my missing exponent's a, so a I'm going to add with the exponent of 6 because those two terms are being multiplied, and then I'm going to take away 2 because I'm dividing by x squared. Okay, all this should equal to my total of 12. So how do I find my a value? I'm just going to isolate from my a, right? So I get 12 plus 2 minus 6. So this should give me 8. So my missing exponent is going to be 8. Right, let's test that out. So I have x to the power 8 times x to the power 6 over x to the power 2. So let's deal with the top first. I have x to the power 14 if I add 8 and 6 divided by x to the power 2. So I do 14 minus 2 to give me 12. And that's what I have on the right hand side. Another question, so we'll call this part A, we'll call this part B. So we're asked to express the following in logarithmic form. So A is saying y is equal to 5 to the power x. So we need to express this in logarithmic form. Okay, so we need to understand what logarithms do. So I'm going to write log of AB is equal to C. So this is a general equation for a logarithm. So it's basically saying log base A, B is equal to C. Okay, so what logarithms do is they're taking this A value and they're seeing what exponent should I raise my A value to give me my B value. Right? And that is what it's the output of the logarithm. Right? So my A raised to some exponent C should give me my B term. Okay, so let's apply this to the exponential form they've given us. So y is equal to the 5 to the power of x. So y is being raised to some power, right? So that immediately tells me that becomes my base, log base 5. Okay, and then it's being raised to some exponent x to give me a term y. So that y is inside my logarithm, and the logarithm should output the exponent that 5 is being raised to. So in this case, it's x. So this entire logarithm is equal to x. Okay, so let's do another example just to see if we understand. So x is equal to 10 to the power y. Okay, once again, we know 10 is being raised to some exponent, so that tells me the base is going to be 10. Okay, so again, the exponent is going to be the output of my logarithm, so log base 10 of x is going to equal to y in this case. Okay, so let's deal with another one. So this is a grade 12 or grade 11 functions question. We're dealing with rational functions. We're asked to consider the function f of x and state the equation of the vertical asymptote, state the equation of the horizontal asymptote, and the y-intercept and the x-intercept. Okay, so if we're asked to find the equation of the vertical asymptote, what we should be looking at is the denominator. When is my denominator equal to 0? So in this case, my denominator is x minus 1. So let's find the vertical asymptote. So x minus 1 is, when is that equal to 0? So if I isolate for my x would end up being 1. So if I plug in 1 into the function, I should get an undefined answer because that position does not exist when x is equal to 1. Okay, that tells me I have a vertical asymptote. So anytime we're looking for the vertical asymptote, we just make the denominator equal to 0, and we solve for what x values will make that denominator equal to 0. Okay, so I said x minus 1 is equal to 0, then I solve for what x is. It told me there's a vertical asymptote at x is equal to 1. So next, we're trying to state the equation of the horizontal asymptote. Okay. The horizontal asymptote we can find by considering the degrees of the function on the top and the bottom. Okay. The degree of the function on the top is just 0. The degree of the function on the bottom is 1. Okay. That tells me I have a horizontal asymptote at y is equal to 2. So let me So this comparison of the degrees happens so that we can understand where the horizontal asymptote is happening, and this plus 2 is telling us the shift of the entire function, right? So this is telling me we're moving it up and down. So first of all, the degree is telling me that the numerator is 0, the denominator is 1, so we know the horizontal asymptote is at y is equal to 0. Right? But we're not done yet because there's a plus 2 at the very end, which means we're adding the plus 2 to this horizontal asymptote as well. So my horizontal asymptote ends up being at y is equal to 2. Okay. So just to recap, if your degree in the top is bigger than your degree in the denominator, right? So numerator, denominator, if your numerator is less than your denominator, these are the degrees. That tells me that I have a horizontal asymptote at y is equal to 0. If they're the same, I'm going to take the leading coefficients and then divide them. So the numerator, leading coefficient from the numerator, leading coefficient from the denominator, and divide the two to give me the position of my horizontal asymptote. Okay. In this case, we had a transformation of plus 2 in the vertical direction, so that means we're moving all my points up by 2. So to find the y-intercept, we know the y-intercept happens when x is equal to 0. So we're going to plug in x is equal to 0 to find what the y value is. And similarly for the x-intercept, we're plugging in when y is equal to 0. Okay. So to find the y-intercept, I'm going to rewrite this function, y is equal to 3 over x minus 1 plus 2. So I'm going to sub in at x is equal to 0. So I have y is equal to 3 over negative 1 plus 2. Right. This simplifies to negative 1. So I have a y-intercept at 0 and negative 1. Okay, to find the x-intercept, I'm going to plug in y is equal to 0. So I have 0 is equal to 3 over x minus 1 plus 2. Okay. So then I'm going to isolate for my x value. So I have x times negative 2 plus minus 1 is equal to 3. Then expand the brackets, minus 2x plus 2 is equal to 3. So x ends up being negative 1 over 2. Okay. So once again, my point will be negative 1 over 2 and 0 for my x-intercept. Okay. So just to recap what we did, we're looking for the vertical asymptote, so we make the denominator equal to 0 and solve for the x values. To find the horizontal asymptotes, we have to consider the degrees of the numerator and the denominator, right? And then if there's any transformations outside that, apply those denoted further to the horizontal asymptote. And for the y-intercept, we make x is equal to 0, sub that in, find the y values. For the x-intercept, we sub in y is equal to 0 and solve the x values. Okay, so let's move on to the next question. So we're dealing with writing an equation for a line. So we're given an equation that it should be perpendicular to, and it passes through a point. So the general form for the line is y equals mx plus b. M is going to be the slope. B is going to be the y-intercept. Right. So they told us to write an equation of a line that's perpendicular to y equals 1/2 x plus 3, and it passes through the point 4 and 0. So we need to find the slope, right? So they've given us a line that it's perpendicular to, so that's helpful because we know the slope of a perpendicular line and the slope of the original, they have to be negative reciprocals of one another, right? So negative of 1/2 and the reciprocal of 1/2. What does that mean? I'm going to flip the fraction. So I have -2 as my slope from my line. So I have y equals -2x plus b right now, right? So once again, to find the slope of a line that is perpendicular to, we get the negative reciprocal. So we change the sign of the slope and then we invert the fraction. Okay, so I've come up with an equation, but I'm still missing the y-intercept. So they've given us a point which is 4 and 0. Okay, so what we could do to find the y-intercept is just sub that point in. Right. So I have 0 is equal to -2 times 4 plus b. So 0 is equal to -8 plus b. B is equal to 8. So my final equation ends up being y is equal to -2x plus 8. Okay, so let's do another one. So this is dealing with a quadratic equation. So a parabola is tangent to the x-axis at 5 and has a y-intercept of -20. Write its equation in vertex form. So if they're telling me that it's tangent to the x-axis, that means it's touching the x-axis at exactly 1 point, at 5. Right? So that's where the vertex should be. So if we write the vertex, the general form, I have a x minus some number, so I'll just call it r squared plus c. Okay, I can figure out the c value because that's just the y value of my coordinate for the vertex. So that's going to be 0, right? So I know the point is 5 and 0. So I'm going to say c is going to be 0 and r is going to be the x coordinate of the vertex, which is 5. So when I rewrite this, I have y is equal to a x minus 5 squared plus 0. I don't need to write the 0, so I'm just going to get rid of it. Okay, so I need to find the a value. They've told me another point, which is 0 and -20, because that's my y-intercept. So what I can do is just plug in these 2 points to find the a value. So I'm going to plug in -20 for my y, 0 for my x, so a times -5 squared. So my a value ends up being -20 over 25. Right. So if I simplify this, this ends up being -4 over 5. So that's my a value. So the final equation would end up being -4 over 5 x minus 5 squared. Okay, so let's go ahead and do another question. So again, still dealing with equations of lines. So they're telling us to find the equation of line between these 2 points. Okay, so we have 4, -1, 0, and 5. So the equation of the line again is y is equal to mx plus b. We need to find the slope and the y-intercept. So the equation for the slope is y2 minus y1, x2 minus x1. Right. So if I say this is 0.2, 0.1, 0.2, my y value is 5, minus my first point is -1, over 0 minus 4. Okay. This ends up being 5 plus 1, which is 6, over -4, which gives me 3 over 2. Okay, so we have the slope for the equation. Y is equal to -3 over 2x plus b. How do we find the b value? I'm going to sub in one of the points, right? So let's pick 0 and 5 to sub in. So I get 5 is equal to -3 over 2 times 0 plus b. This entire term goes to 0 because anytime I multiply by 0, I end up with a 0, so b is equal to 5, right? So my equation ends up being y is equal to -3 over 2x plus 5. So let's change things up. So we're doing a data management question. So they're telling us how many distinct arrangements are there of the letters of the word management. Okay, so distinct arrangements. So in order to find distinct arrangements, we need to eliminate the similar letters, right? A is repeating, E is repeating as well, right? And we also have N repeating. So when we write the equation for the permutations, we need to say there's 10 letters in total, right? So 10 factorial divided by the repeating numbers, right? We are repeating A, we're repeating E, we're repeating N, right? And sorry, we forgot one. We're repeating M as well, right? So we're repeating each of these twice. So 2 factorial, 2 factorial, 2 factorial, and 2 factorial. So each factorial in the denominator is telling me what I'm repeating. So this is repeating E, this is repeating A, this is repeating N, and this is repeating M. Right? So if it's repeating more than that, if I find 3 A's, for example, I'm changing my factorial to 3 then. Okay, so I'm going to simplify this. So 10 factorial over 2 times 2 times 2 times 2. Right? That's what 2 factorial simplifies to, which gives me 10 factorial over 16. So this is the total number of distinct combinations that I can have if I want to combine the letters in management. We just need to account for the repeating letters, right? M and A and E were repeating, so I needed to divide 10 by those repeating numbers. Okay, so that about does it for us today. So thank you for tuning in. Hope this has been helpful. Once again, if you have any questions, you need some help with any questions, send us a message. We'll be happy to help you out. We do lives like this again once a week. Our next lab will be this Wednesday. So send us your questions so that we can do them on the live, or we can help you out individually as well. Okay, so this has been T from Ask Zylor signing out. Hope you have a good night.